When I returned from a family vacation in early July 2021, I found that my home lab PC would not boot. Having a working PC is pretty important to me. I use it for all of my electronics hobby work, as well as video recording and editing, and during the 2020-2021 academic year, I used it for remote teaching. So I was motivated to get it working again. Eventually, I was able to determine that the problem was the motherboard, an Asus H81M Plus, which I had been using for several years after purchasing it used on eBay. At this point, I had to confront the reality that consumer motherboards for Intel Haswell CPUs are becoming somewhat difficult to find. I browsed for motherboards on eBay and Newegg, but I felt that the prices were somewhat high for hardware that is now 6 or 7 years old. I considered taking the opportunity to upgrade to more modern hardware, but given that I would need a new CPU, motherboard, and memory, I estimated that I would need to spend in the neighborhood of $600 to get a system that was a noticeable improvement over what I had previously. That option didn't appeal to me since I would be abandoning my totally functional CPU and memory. What I really wanted was a way of keeping my current PC running. The good news is that there is a nearly inexhaustible source of inexpensive, high-quality, older generation PC hardware, decommissioned office PCs such as the Dell Optiplex series. This topic has been covered extensively on YouTube, most notably by the Game Bench. For my purposes, the Dell Optiplex 7020, Optiplex 9020, and Precision T1700 mini tower systems were the systems closest to my original hardware, since they support 4th generation Intel Haswell CPUs, like my PC's Core i7-4790K. These systems are readily available on eBay, both in the form of complete systems and also individual parts such as motherboards, fans, and other system components. So I decided to fix my home lab PC by replacing the motherboard with a Dell Optiplex motherboard. This would satisfy my goal of fixing my current PC rather than completely replacing it, and since Dell motherboards supporting 4th generation CPUs only cost about $25 on eBay, I could buy some spares that would allow me to keep the system running in the event of future hardware failures. A significant quirk of the Dell Optiplex and Precision systems is that they use somewhat proprietary connectors for power, fans, power switch and LEDs, and front panel I/O. To a large degree, adapters are available to allow the use of Optiplex motherboards with standard PC hardware. For example, adapter cables are available to adapt standard 24-pin motherboard power connectors to the proprietary 8-pin connector that Dell motherboards use. Adapter cables are also available to allow standard 4-pin PWM CPU cooler and case fans to be used with Dell's proprietary 5-pin fan connector, and a company called Harbin Repairs makes adapter PCBs allowing standard ATX front panel power switch, LED, and I/O connectors to be plugged into the proprietary Dell motherboard connectors. Another quirk of Dell systems is that they have a thermal sensor to monitor the air temperature inside the case, which connects to the motherboard using a 2-pin connector. If a thermal sensor is not installed, a system error will be generated on boot, so when installing a Dell motherboard in a standard PC case, you will want to make sure that you have a compatible thermal sensor. Armed with this knowledge, I ordered the following parts: a 24-pin to 8-pin PSU adapter, an Optiplex 7020 motherboard part number 8WKV3, a Dell CPU cooler part number G8CNY, a Dell case fan part number WC236, a Dell thermal sensor part number R434D, and a Harbin Repairs front panel adapter kit. In addition to ordering these parts, I also made a small modification to my PC's case, adding an LED to the front panel. In addition to having power and hard drive activity LEDs, Dell PCs also have a diagnostic LED, which is used to display diagnostic codes in the event that the system fails to start up properly. Since this is very useful for troubleshooting, I thought it would be a good idea to have this LED available. Once the parts had arrived, I removed the old motherboard and CPU cooler and installed the new hardware. At this point, I ran into an issue. The system would not boot. The diagnostic LED blinked in a pattern indicating an issue with the power supply. This illustrates one potential issue with running a Dell motherboard with a non-Dell PSU, which is that not all ATX power supplies will work correctly with a Dell motherboard, even if you use the 24 to 8-pin adapter cable. After some research on the Dell forums, I saw the EVGA 700BR power supply mentioned as one that was likely to work. After a quick trip to Best Buy and swapping out my old PSU for the new one, the system booted right up. Once the system was running again, I did some testing and overall I was pleased with the performance. One issue that I noted, however, is that during CPU-intensive tasks, such as video rendering, the CPU core temperatures would reach 80 degrees Celsius, which is higher than I wanted. I concluded that the stock Dell CPU cooler was not quite up to the task of cooling my CPU, which admittedly is one of the more demanding Haswell CPUs to cool. Dell motherboards have a proprietary CPU cooler mounting system, which means that some work is required to install a standard CPU cooler. Fortunately, I found a video by Escotech showing how to mount a standard 92mm tower CPU cooler on a Dell motherboard. The technique involves removing the springs from a stock Dell CPU cooler and then using M3 bolts to fasten the CPU cooler to the motherboard. After installing a Cooler Master Hyper TX3 CPU cooler using this technique, my CPU core temperature stayed below 70 degrees Celsius during video rendering. Overall, I spent about $220 on the repair. The total cost would have been significantly less if I'd been able to use my original power supply. However, I'm very satisfied to have the system working again. Even better, I have 2 spare Dell motherboards which I could easily swap into the PC at any time, so I expect to be able to keep this system running for several more years. I'm planning to make 2 more PC Tech videos in the future. One will cover the construction of a PC test bench for validating motherboards, CPUs, memory, and other system components. Another will cover building a new PC to use at work. Thanks for watching, and I'll see you in the next video.